Still staying with section 1, 11.1, page 167 onwards. These are now standalone questions, and here's question 4, rated at grade B. Not going to read it. Essentially, D is the centre of the circle, which is fine. This chap thinks that angle ADC is 65, so he's saying it's 65 degrees. That's a great big question mark there. Show that this guy is wrong by actually working out ADC. Now what have we got here? It's seemingly a cyclic quadrilateral, but it's not, because this vertex here is at the centre. Had it been over here, say, and we had a cyclic quadrilateral, then that would be in fact the case, but it's not. This is how I like to teach it. If I know I can create a cyclic quadrilateral by doing that, for example, then I know for sure that opposite angles add up to 180 degrees. Therefore, I know that this angle that I've created must be 50 degrees. Is that alright? So 130 plus 50 degrees makes 180. So therefore, the angle at the centre, if you look very carefully, the angle at the centre will be twice the size of the angle at the circumference I have drawn. If you can imagine, therefore, a chord going from A to C, we have from the same chord an angle subtended at the centre and an angle subtended at the circumference, drawn from a common chord. So, and they're in the same segment anyway of the circle. So if that's 50 degrees, then the 65 is in fact wrong. So now I will rub it out and I'll put in the correct answer. So that's going to be, do it over here, 2 lots of 50 degrees, and that's therefore going to be 100 degrees. Okay, so I've just proved this Assad chap is wrong. This is the next question, question 5. It's rated at grade A. Lots and lots and lots of words there. I've got the centre of the circle, which is likely to be significant. I've got to write down, please note, write down angle QSP. Angle QSP. It wants that one. If it says write it down, the hint is there's nothing to calculate, because look, if PQ is a common chord, then the angle at the circumference, called 52, is equal to the angle QSP, because it's coming from the common chord in the same segment of the circle, and they're sitting on the circumference. So straight away, that's 52 degrees, alright? And I've got to write down angle QOR. QOR. Well, that's that one there. Well, I'm told to give my reasons when I'm speaking them. So, what have I got here? If that's the centre of the circle, then I reckon that is a radius, as that is a radius. If these two lengths, QO and RO, are radii, we have an isosceles triangle, which means that angle RQO is also 52 degrees. I have an isosceles triangle, therefore I can work out angle QOR. QOR. So I point over here, I've got 180, take away 2 lots of the 52, because it's an isosceles triangle, 180, take away 104, and that's going to give me 170, please, that's going to give me, no, I was right before, 76 degrees. What's wrong with me? I'm tired. 76 degrees, so QOR 76 degrees. Next one, this is question 6. We have a diameter there, I know that because we have the centre 0, 0, honestly, centre O that's labelled for us, and we're given an angle, that's x, that's 2x. Now if this is a circumference there, and this is touching the circumference, that has to be 90 degrees, because this triangle is being drawn from the diameter. The diameter is the chord which creates this triangle, and at the circumference this will be 90 degrees. You just know that as a simple rule. I've got a simple equation. I've got to work out the size of angle MNL. MNL. In other words, I've got to work out the 2x angle. Let's first of all get an x. Simple equation. 2x plus 90 comes to 180 degrees. Straightforward. That's the angle in the triangle. So 3x's come to 90 degrees. So a single x is going to be 30 degrees, and therefore 2x is going to be 60 degrees, and that's angle MNL, 60 degrees. Okay, straightforward. Turn over. This is question 7. Write down the value of x. Here we go again. Write it down. If we have a common chord across there, then that 40 at the circumference equals that 40 at the same circumference, and therefore that's 40 degrees. X equals 40 degrees. Angle Y, we have a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are supplementary, so this plus this are opposite angles, add up to 180, therefore Y is going to be 180, take away the 40 degrees, therefore Y is going to be an obtuse angle of 140 degrees. Now I've got to prove something here. This is question 8, again grade A rated. I've got to prove that angle SRP is 40 degrees. So okay, so I know what I've got to aim for. If this would just please write, I'd be really happy. There you go, SRP. What have we got here? Let's just talk about this. That's 100 degrees across there. This is an isosceles triangle because I'm told that PQ equals PS. So if that's 100, I've got 80 degrees left to play with. So that angle is worth 40 degrees, and this angle is also worth 40 degrees. What have I created? Look, I have an angle at the circumference, that is PRS coming from this chord, and I've got an angle at the circumference called PQS, and that happens to be 40 degrees because I've just calculated it. Therefore, PQS and PRS are the same because they're in the same segment, and they are drawn from the common chord touching the circumference. Angles in the same segment are therefore at the circumference will therefore be the same, hence that's 40 degrees. And I didn't write all those words down, but I've proven it with my words, and when you come to actually do this in the exam, use a few words just to chivvy the calculation along, to explain to the examiner exactly what you're doing and why you did that. Use things like isosceles triangle, therefore PQS equals 40, and angles in the same segment drawn from the same chord touching the circumference are identical, hence angle PRS is also 40, and therefore it's been proven. Okay, next question. I have a quadrilateral, definitely not cyclic, simple reason, I'm drawn to the centre and not drawn to the circumference. But anyway, don't be fooled by thinking Q is opposite 150 and R is opposite the 65. It doesn't work like that. I've got to calculate the other two angles. Very, very easy. Now look, here I have an angle at the centre. If I imagine another triangle coming off the chord PR, then I know that the angle at the circumference will be half the angle at the centre. So half of 150 is going to be 75 degrees, so that's 75 degrees. Now look, I've created a cyclic quadrilateral, therefore this angle will be 180, take away the 75, that's 105 degrees. Alright? Now I have three angles in a regular quadrilateral, and I can now work out the fourth one. How do you do that? Well, angles in any old quadrilateral, whether you're trapped inside a circle, a part of a circle, or wherever you are, you have a sum of 360 degrees. So here I go. What have I got here? So I can call it angle ORQ. That's the R angle there. Is going to be 360. Take away the 150. We'll take away the 65. We're going to take away the 105. And hopefully we get a nice little answer there, shall we? Grab my machine and do it on this little board here. Right, 360, take away the 150 at the centre, take away the 65 on the left hand side, take away the 105 at the bottom, leaves me with 40 degrees. So therefore angle R there, or ORQ, is 40 degrees. Alright, please work, lovely. Any more? Let's just turn over and see what we've got. Oops, dropped the pen. Right, there's two more. Now these are the ones with great big fat fuzzy purple question marks. They're supposed to be difficult. I don't think they're all that. I hope I don't get stuck doing these off the cuff. Right, quite simply, question 11, page 169, work out angle A and work out angle B. Well, let's just do that. Isosceles triangle, great, and here's a different isosceles triangle, also great. Right, I've got 140 out there. I reckon the leftovers on the straight line will be 40 degrees because 140 plus 40 makes 180. Look, isosceles triangle, therefore A is also 40 degrees. That's all there is to say about that one. Now what about this horrible little angle B? I'm thinking. I reckon it could be useful to work out this angle right here. If I have an isosceles triangle, I've got a 40 and a 40, which is 80. That leaves me with 100 degrees left, because all angles in a triangle add up to 180. And I can see I've now created a cyclic quadrilateral. Look at my pen. Alright, four-sided shape, and opposite angles in a cyclic quadrilateral where the four vertices are touching the circumference, opposite angles are supplementary. So I reckon this angle right here, opposite the 100, is going to be 80 degrees. Is that okay? 80 degrees? Supplementary angles. Now I have another little skinny isosceles triangle there trapped in my circle, and if these are equivalent lengths, then these will be equivalent angles. If that's 80, then so is that 80 degrees. I'm up to 160 degrees so far, which makes B 20 degrees. 180 take away 160, let's just write it down, is going to be 20 degrees. A little bit tricky, but not very difficult. So angle A is 40 degrees, angle B is 20 degrees, and we've got ourselves probably an A star for that. Question 12, similar sort of heartache. I've got to work out angle X. Okay, I've got a great big isosceles triangle. If that, I'm just thinking outside the box here. If that's angle X and they're touching the circumference, that one and that one, that's also angle X. It could be useful, it may be useless. I'll just put it in there for now. What else have we got? Oh look, I've seen it. That is a diameter because it's passing through the centre O. If that's a diameter and I've got a triangle touching the circumference, then this part there, if you please draw, this part is 90 degrees. Is that okay? So that's 90 degrees, which makes this part not 90 degrees, but the remaining 46 degrees. Alright, so if all of this is 90 and this little part is 44, the leftovers are 46 degrees, because 90 take away 44 is 46 degrees. Lovely. So that's 46. Now this is an isosceles triangle. That's an isosceles triangle. Therefore, if that's an isosceles triangle, if I then take 180 degrees and take away my angle of 46 degrees, that one, and divide by 2, I get an angle there and an angle there, which they both happen to be x's, by the way, because that's equivalent to the x over there. So let's just work it out. 180 take away 46 comes to 134, and then we divide that by 2, and that will give us something, and there it is, 67 degrees. So that x is 67 degrees, that x is 67 degrees, and because this is isosceles, incidentally, that x is also 67 degrees. Let me just tidy up that little bit, doesn't look very nice. I want it to look pretty. So which is 67 degrees, and that's what x is. Is that alright? I think that's okay. Yeah, I think that's right. So I'm going to stop now, have a little breather, have a cup of tea, and I'll be preparing for 11.2. Now I know 11.1 was a bit long. The reason is I did the majority of the questions. Each one has its own particular challenges, and obviously revise the rules. Look at the introduction to this chapter 11, look at the rules, look at the thinking, look at all the examiner's tips, and then launch into the questions with me and see how lovely they really are. And I'll see you quite soon.